an hour on the homework. At least 2 hours. At least 3 hours.
I don't really remember. I started
At least 4 hours. 5 hours. 5-ish. We lost people around 5.5. You spent your whole life waiting for that assignment? I had a student in one of my grad classes last week spend 25 hours on a homework assignment.
That's awesome.
No, an easier one actually.
What?
But they're grad students, but they're in the IT program.
Okay.
Actually, it might not have been easier. It was probably harder than this one. But.
They're a grad student and it was easier than that?
Well, but this is MSIT. That doesn't necessarily assume that they've had a programming background. So it's kind of the same class as this, but they're farther into the class because their class meets for 8 weeks, 4 hours per week. It's a terrible way of teaching programming, but it is what it is. Okay, so our homework was to write some code necessary to convert a decimal number, so any decimal number, to the binary equivalent and display the binary answer in the correct order. So I gave you an example in class. So for example, if we were converting 42, you're going to divide by 2 over and over again, recording the remainder, and then remember we read it from the bottom up. All right? So we're going to write this as just code in main first, and then we're going to talk about functions. We'll bring it into a function, and then we're going to write a more generic version of this. So let's get Adam open here. Who?
That's a lot of files.
Where? In Adam?
Yeah, on your left side.
Oh, yeah, that's just the directory. I got stuff. Yeah, I always got to figure out which, so this is Android Studio. This is what we'll be doing next semester. So I got to pop that open sometimes. And I have a C compiler on here that we mess with. And you never know what language you're, usually takes me 5 minutes to groove into whatever language we're doing that day. This is Python, right? We're writing Python in here. But that's actually good. Shut up! That's actually good because when you have multiple programming languages and you see that the language doesn't make a difference, right? You know, you whether you're doing Python or C++ or Java, you just got to kind of get into the little rigmarole for that language that day. But it's just programming is programming. The language doesn't really make a difference. All right, so we're going to start with some decimal number. So we're going to start with, since our example was 42, we'll start with 42, but you're going to see we'll be able to change that guy to whatever we want. All right, then we're going to have our answer. Our answer is going to start off as the empty string because we're going to be building up a string that is going to be our answer. All right, now if you look at our pattern here, we keep going until we finally get a divisor that is 0, right? We finally get something that comes out to a 0. I guess it's a quotient, right? So we'll go ahead and say while answer is greater than 0. So as long as we haven't, decimal. As long as we haven't whittled decimal down to 0, we should keep going. All right, so what we need to do is we need to record the remainder first, then change decimal. So we're going to say, I'll just create a variable here just to keep it as some separate stuff, and then I'll shorten it. So we'll call it cur remainder is equal to the current value of decimal mod, and we're doing binary, right? So this will give me the divide by 2 and store the remainder in there. Then I'll go ahead and I'll say answer is equal to answer concatenated with cur remainder. And we're going to end up building this in reverse, and then we'll fix it up here in a second. Then we want to go ahead and update decimal. So decimal is equal to decimal divided by 2, integer division. And that will whittle it down, right? So what am I doing here? The very first time through, I'm storing the 0. That's my current remainder. I'm storing that 0. I'm adding it onto a string called answer, so I'm remembering that. Then I'm whittling down the 42 to 21. Those are the 3 things I did there. I store the remainder, and you make sure you store the remainder before you do the division. Okay, otherwise you'll be having the remainder for the wrong division. All right, so we store the remainder, then we went ahead and concatenated that remainder onto our string, then we whittled down decimal. We're going to keep doing this over and over and over again until decimal is finally a 0. When decimal is finally a 0, that means we're done. So we fall out of this guy, and we print answer. Now, right now, answer should be in reverse. Should be in the wrong order. Remember, we read from bottom up. So let's go ahead and run this guy. Let's see where I am. Was this on my desktop or in downloads? Desktop. All right, so we'll do Python 3, CSC200.py, row. Oh, I'm storing it as a. So my current remainder here, this guy's actually a number. I need to make this guy a string in order to concatenate it on. Otherwise, concatenation won't work. All right, so there's my 0, 1, 0, 1, 0, 1, which is the right answer, but in the wrong order. Right?
Yeah.
So now we have a couple of options. We can write a function that reverses a string. We can call the little reverse function. Or we could have just built our string
Are you serious?
in reverse. So there's.
Why does that work?
All right, so let's look at this. This isn't like a weird trick. Okay?
Definitely worth 4 hours. Trying to get that string.
Okay, well let's assume you could. But let's explain it this way, and then we'll write an alternative. Okay? So we'll look at it a couple different ways. So first of all, what's string concatenation? If I have a string, let's just say s is equal to, let's say hello, and then I want to say s is equal to s plus, I don't know, we'll say w. All right, that's going to give me the resulting string hello w.
Mm-hmm.
So hello, yeah, that. All right, but now if I say w plus s, both of these are strings, right?
Mm-hmm.
I can glue them together that way. Now it'll be Whello. W-H-E-L-L-O. So I'm just building it by tacking on to the front of it rather than tacking on to the end of it, which effectively then builds it in reverse. Does that make sense?
Yeah.
Okay, now first of all, I think I told you this before. It will always, well, for a long time, for several classes now, when you see the solution, you're going to be like, that was it. Okay? And it only took him 45 seconds to write. I spent hours and hours and hours and hours and more hours and more hours. Remember back to the first week of class, I said this is like a sport, right? I've been playing this sport for a few minutes. Okay? You're just getting started. So you need to put in those reps in order to get better at this. Okay? You know, well, probably by the time you're done with this class, a question like this would have been pretty easy. You'd be able to sit down and probably write it in like 5 minutes or something like that, just kind of figuring out the logic in your head. Now, let's assume here that we couldn't come up with the idea that we had to tack onto the front. All right, let's assume that we've built it in reverse and we don't know what to do. All right, so now what we can do is we can just write some code that reverses a string. So I can come down here and I can say, we'll call this guy new answer, start him off with the empty string. I'll write a for loop that walks through answer backwards. So for I in range, we want to start at the last legal bucket at answer, which is the length of answer minus 1. Keep going as long as we're greater than -1 and step by -1. And then we're going to say new answer is equal to new answer concatenated with answer at bucket I. And then at the end, we'll print out new answer. So that's fine as well. So this is the same result. We just, instead of building our string in reverse, we built our string, well, instead of building our string in the right way, we built our string in reverse, and then we had to reverse it to get us our correct answer. So that's some code that reverses a string. So there's the same result with the reversing thing. That make sense? Now, if we want to change our 42 to 138, this guy will still work. There's 138 in binary. So this works for any decimal number to binary. 2, 3, 4. Well, I mean, I didn't change my logic at all. It's just a different answer. There's the answer. It's 138 in binary. This is the ones place, 2s, 4s, 8s, 16s, 32s, 64s, 128. So this is 128 plus 1, 2s, 4s, 8 plus 8 plus 2. Good. I'm using, what are you talking about?
Like, is that like on the Mac or are you using, cause like, I use like idle when it is, like.
Oh, yeah. So, I open up terminal. So terminal is what I'm running here. What's already installed on the Mac, if you do just Python, that's you actually have version 2.7.
Yeah.
So if you go to Python's website and you download Python 3, which is what the version of Python the book uses, because actually there's two supported versions of Python. There's 2.7, there's Python 3 point whatever, and they both are live. So the book uses Python 3, so there will be some examples where Python 3, the syntax is different. That's why they both are alive. There was a bunch of people that had stuff written in Python 2 that did not want to convert it to Python 3, so there was this big uprising. That's why they kept both. So I downloaded Python 3, installed it, so then to run Python 3, I just type in Python 3. And that's the Python 3 version. But Python 2.7 comes with the Mac. So if you go out to terminal right now and you type in Python like this and press enter, it'll open up a Python interpreter here.
Is that possible on a Windows computer?
Effectively, when you download Python, you already are doing that. You're using, if you're using their idle thing, that's their IDE for doing Python, for typing it and running it. That's just the special tool that came with it that kind of replaces Atom. But when you install that, Python, you're getting an interpreter just like this. So you can open up your command prompt and run it.
I believe you said, right?
How do you open a specific file?
You can just
I was in trouble. I couldn't.
How do you open a specific file on Windows?
Like to open a
We don't have
Python 3 file to run it. The
Okay.
interpreter only accepts single
How do
lines.
you do it? Okay, so
Well, that's only if you're running the interpreter. So when you run the interpreter, you open up command prompt, right? You type Python like this, and it looks like something like this, right? So to get out of this, just do the quick command. So now what you'll do, if you want to, let's say you're in the directory of the file, you just type in Python. There's my name of my file, just like that.
But you have to make sure you save these.
You won't need to because that's the only version of Python was installed on your machine.
Oh, you just type in like the file name and it'll run it.
Well, you type in the interpreter, which is Python 3 on my computer because Python's the 2.7 interpreter. Although this will work in Python with 2.7. There's nothing we're doing special here. So this is the name of my interpreter. I'm suggesting you use Python 3, but on Windows that probably just installs as Python.
Yeah, if you don't have an interpreter.
Yeah.
Or if you only have one interpreter, I think you don't even.
Yeah. So you just type Python space the name of your file.py and it runs it.
I can just type in the file name and run that back.
That's because of the MIME type on it. So if you just do this and press enter, the PY is getting recognized as a Python executable, and we'll run it. But I wouldn't necessarily bank on that. It depends on how, I guess, the installer necessarily worked. Okay, so questions about this guy? Not too bad. So if we go back to the, let's call it the better solution. I don't want to talk about it. Okay. See, I told you it was easy.
You said it was going to be really, really hard also.
Now, let me ask you this. What if I wanted to convert, instead of to binary, what if I wanted to convert to octal?
Oh,
Just
that's all you have to do.
change the 2 to an 8. Now we'll convert 138 into octal. Identical pattern like we did in class, right? So there's the octal version, 212, of our number 138. What if I wanted to do base 3? Change it to 3. What if I wanted to do hexadecimal? I change this to a 16. Well, sort of. Remember, my favorite hexadecimal number is 2989,
Yeah.
right?
Print out that.
So this should give me bad, but it's not going to give me bad. It's going to give me an 11, which is a B, a 10, which is an A, and a 13, which is a D. But it hasn't done the mapping for those guys.
So you'd have to add something to the
Well,
mapping.
we have to do a little extra logic. So let's look at what that extra logic might look like. So if I want a 10 to become an A, or an 11 to become a B, so on and so forth, anybody have any, based on what we know right now, any suggestions on how we can make that work? Go ahead.
Well, above all the code, you could put like an A equals 10, because when it gives out when it does the math, it stores a 10 in the string or current reader, and then so it should convert it to a 10 when you print it out.
If you're locked.
You should convert it to a 10 when you print it out.
I'm not sure. It's just,
You just assume it's maybe magically might just do it.
if you put A equals 10 or something.
Okay. Go ahead.
Put an if statement in the while checking for the if 10 then set decimal to
Okay, so we could do some crazy if statements. So we could do something like that. Here's our current remainder. So before we tack our current remainder onto our answer, maybe we ask the question, if current remainder is greater than 9, we need to do some stuff, right? Okay, if it's greater than 9, then we'll ask if current remainder is equal to 10, set current remainder equal to A. Elif current remainder is equal to an 11. We'll just do it enough to make BAD work. Current remainder is equal to a B. Elif, it's a 12. We'll make it a C. And then I'll just throw an else in here so it'll work for just my BAD for the moment. Cur remainder is equal to a D. Okay, so this only works up to a 13. This is what this guy will work for right now. All right, so I'll get my current remainder, but then I'll potentially change it. I'll say, look, if it's bigger than 9, I need to map it to some letters. So here's where I'm doing a partial mapping. So there's my BAD. Now, if you want this to work for hexadecimal, you'd have to go through F. If you want this to work for the entire alphabet up to base 37, you'd have to go through you know, A through Z. This seems like there's probably a better way
Probably.
than having a gigantic if statement here. Any suggestions based on what we know right now?
I feel like I know, but I just can't.
Put yourself in kind of, I think at some point I mentioned like the show MacGyver, right? So we want to put ourselves in MacGyver mode where we're having to solve problems using the crap we have laying around us. So you want to think about the tools that are currently in your toolbox and say, is there something I can do here to make this work?
Can
Go
you
ahead.
use a list or a dictionary to assign the variables to
Can you?
I think.
It's not a horrible idea. What are you thinking? What do you want to have in your list?
I don't know. I mean, you could input all the letters, all the values, make like one giant list, and then like there, if I remember right, there's like a function that can work through the list and assign each individual element of that list to something else. You could try and do it that way. I don't know the specifics, but
Well, I mean, one thing we could do is so if we kind of go down that path, we could build like a massive dictionary up here.
right.
So maybe call this guy map, and we'll have map equal maybe a 1. Actually, let's do this. A 1 maps to a 1. A 2 maps to a 2, so on and so forth. A 10 maps to an A.
Yeah.
An 11 maps to a B. A 12 maps to a C. A 13 maps to a D. 14 maps to an E. 15 maps to an F. And I got to fill in the rest of these guys here. So then I'll have a 3 maps to a 3. A 4 maps to a, well, actually, let's take those out for now. Then I'll show you some other things. Okay, so maybe we have a little mapping thing like that.
Yeah, the colon after the E. Do you think you'll need a?
Oh, let's see. E maps to a 15, like that.
Is map a function?
No, this is just, it actually is a function, so we need to make it something else. Call this guy hex mapper. Okay, that's our hex mapper. All right, so now what we'll do is, if we're saying it's greater than 9, we'll actually say cur remainder is equal to hex mapper at bucket cur remainder.
Oh, sweet.
So if it was a 10, it'll give me an A. If it was an 11, it'll give me a B, so on and so forth. Let's just run this real quick. So there's our BAD. Still works. Go ahead.
What is that, the buckets after Hexmapper do?
This says Hexmapper is a dictionary. This says give me the value that lives at that position in Hexmapper. So cur remainder is going to be either a 10 or an 11 or a 12 or a 13 or a 14 or a 15 right now. So if I go to bucket 10 in Hexmapper, the value that lives there is an A. If I go to bucket 11, the value that lives there is a B. That make sense? Now, could I make this any better without having this if statement? I started writing this a second ago. I said, well, if it's a 1, well, we probably need to have zeros as well, right? So we'll say if it's a 0, have that map to a 0. If it's a 1, have that map to a 1. If it's a 2, have that map to a 2. If it's a 3, have that map to a 3. If it's a 4, have that map to a 4. 5. It's a 5. 6 is a 6. 7 is a 7. 8 is an 8. 9 is a 9. All right, so now that covers all of them, right? And we're always going to get strings out of here.
Mhm.
So I'll get my numeric remainder. Then I'll update cur remainder with the result of hex mapper. So now cur remainder will always hold a string.
Okay.
Then I'll go ahead and tack it on to my answer. Still BAD. I'm mapping even numbers. I'm passing it. If I pass it the remainder of 3, it's going to spit out the string 3. If I pass it a remainder of 5, it'll spit out the string 5. So on and so forth. That make sense?
Mm.
Now this was a little bit tedious to write, wasn't it?
Yeah.
I'm going to create another hex mapper. Just going to write it like that. Do I? Well, that would be a problem. All right, so it's just a string filled up with all the numbers and all the letters that I'm interested in. And I'll just replace hex mapper here with another hex mapper. And we see that this guy still works. So this guy is a string, right?
Mm-hmm.
Yeah.
What character lives at bucket 0 of that string?
0.
What character lives at bucket 1 of that string? What character lives at bucket 10 of that string? Bucket 15 of that string. So I can just keep going with my alphabet here. All right, so now I can say 2989 in base 30. That's 39J in base 30. Because we've investigated the pattern of converting values, right? This is our pattern of doing the divide thing, recording the remainders. It's the same exact pattern no matter what the base is. We just have to have that additional ability to handle remainders of values greater than or equal to 10, turning them into letters. And that's what this guy right here lets us do. So this hex mapper worked just fine. It's just a little bit tedious, right? Similarly, we could have created a list that had, you know, if I wanted to, let's call this guy list hex mapper. So this guy would be the list containing a 0, containing a 1, blah, 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 containing a F. Bucket 0 would be the string 0. Bucket 1 would be the string 1. Bucket 15 would be the string 15, or string F. So we're using all 3 of those things in the identical way. Go ahead. Oh, no question. But certainly for this type of problem, this mapping makes life a little easier.
Yeah.
So what we're doing is we're taking advantage of how strings work. I just happen to put characters next to each other in a very specific order in a string. That if I ask for the thing that lives at 0, it gives me the 0. If I ask for the thing that lives at bucket 10, it gives me the A. It effectively does the exact mapping we need to do. Okay, this isn't some feature that's built into the language that's just made for converting for bases. This is just how strings work. I just happen to have found that laying around in the garage, and I decided, oh, maybe this tool over here I can use for solving this problem. You know, like when you try to pry a jar open with a screwdriver or something like that. You know, it's effectively what we're doing, right? All right, so now it would be helpful if I could take all this stuff and throw it into a function. because we might want to convert something multiple times. So it would be nice to be able to store this guy in a repeatable chunk of code. So we're going to talk about functions for a few minutes here. So this is a reusable chunk of code that we write once and then can call multiple times. Now, functions may require inputs so that they can accomplish what we want them to accomplish. So that's the generic definition of a function. So for example, if I go back into our code here, and I go ahead and I write a quick function up here, I'm going to define something. We're just going to call this guy addNums, and he's going to take in 2 parameters. And I'm going to return a plus b. So this little, so this little function right here will take in any 2 numbers. Well, any 2 parameters, actually, since this is a loosely typed language, but let's assume they're numbers. Take in any 2 numbers, add them together, and spit the result back out. So I can do things like print the result. Well, here, let's put it in a variable first. Result is equal to addNums of 5 and 7. And then I'll go ahead and print result. So there's 5 plus 7 gave me a 12. Any 2 numbers I pass to this guy, it will add them together and spit the result out. So if I call that same exact function another time, and I pass this guy a 21 and a 2008, I'm calling the identical logic, addNums here, that takes in any 2 numbers. The first number is A, the second number is B. So the first time I called it, 5 came in for A, 7 came in for B. I added 5 plus 7. I added the current value of A to the current value of B, returning the result, and I got the 12. The next time I call addNums, I'm passing in a 21 for A. I'm passing in a 2008 for B. It's going to add those 2 values together and spit the result back out. I happen to be storing the result inside of a variable there called result, and then I'll print that out. So 2029 is the sum of those 2 numbers. Now, nobody says I actually have to store this in a variable. AddNums here, this guy right here, boils down to a value. I just happen to be putting that value into a variable. Nothing keeps me from saying print addNums 37 negative 5. I can't use it again after this, but I get the answer and I'll print the answer out. So this should give me a 32. There's my 32. Because I'm directly using the result of my call to that function. I'm not putting it anywhere, so I don't have access to that 32 after this line. Where I do have access to the 12 after I print it out here because I happen to have stored it inside of a variable called result. I've remembered it. I've used my memory to remember that value in case I need it again. That make sense? How functions work? So we're just taking logic that we've already learned how to write, and we're throwing it into a nice little kind of portable container that we can throw parameters into and have it spit out results. So what I'm going to do here is I'm going to take all my logic here for my number conversion stuff. And I'm going to write a function. This guy's going to be called decimal to base. So it'll convert a decimal number into any base. So I need it to give me the we'll just spell it out. Decimal number. Actually, let's just call it decimal since that's what we named in our code. And then we needed to take in the base, or if you want to be more mathy, you would call it the radix. It's the mathy version of that. That's something to what base it's in. But we'll call it base here. I'll go ahead and paste all that code in. So decimal to base requires two different inputs in order to work. It requires the number I'm trying to convert and then what base I want to convert it to. I'll go ahead and take out our extra couple of mapping things here since our string one was kind of the nice one. So this loop says as long as decimal is greater than 0, decimal is whatever was passed in here, and instead of 30, I'm going to divide by base, whatever base is. That make sense? All right, so this is my function decimal to base. I can pass in any decimal number and any legal base, so that's a base 2 through base 37. And it will calculate the result for me. Now, at the end here, answer holds my final answer. I need to ultimately return that. That way it spits out of my function call, and I have that result to do something with. So now what I can do down here, I can print out decimal to base of 2989 and tell it I want it in base 16. That make sense? So I'm going to call upon this function that I wrote here, and I'll pass it my decimal number, and then I'll pass it the base I want it to convert it into, and then I'm expecting to get a BAD out of this, right? So there's my BAD. Now, if I want to go on the very next line, and I say, you know what, I want to see what 2989 in base 11 is. I can call that exact same function, but pass it a different version of a different base. And now I'll get, this is base 16, this is base 11 of the decimal number 2989. That make sense? If I want to see them all, what if I want to see the value of 2989 in base 2 through base 36? Write a loop, right? And what's that loop going to do? Just help me write the loop.
Let's see. Do you want to start it? Did you want to start at 2 and add up?
Sure.
Okay. Where are we going to?
The 36 including 36.
Okay. So while
We'll do a 4.
what? We're going to do a 4.
Yeah, I'll do a 4 loop. So for I in range. Or you were going to while loop logic?
Yeah,
All right, that's fine.
I was.
That's fine. That's fine. We'll do a while loop. So what do you want to start I off at?
We're going to start off with 2, right?
2. Okay, and I want to keep going as long as what's true.
As long as I is.
I want to go up to 36, including 36.
Equal.
Want to do less than or equal to 36?
Yeah.
Okay, and then I want to print out base to our decimal to base 2989 and what base?
I.
Base I. Okay. Is that it?
No, we need to change I also. So we're going to have I equals I plus 1 to 2.
Okay. So the first time it will be 2. This will print out 2989 in base 2. Then it'll go to 3. This will print out 2989 in base 3. Base 4, base 5, base 6, so on and so forth, all the way up to base 36. And I'll paste this code up on Slack when we're done.
Okay.
So there is 2989 in all of our bases. Not too bad.
Pretty sure that code is shorter than mine, and you did all base.
But it's supposed to be that way.
I know.
Now they certainly wouldn't put like if I was, they wouldn't put a programming teacher in front of the class that like doesn't know how to program. That's more of like a high school approach, right?
Yeah.
Or like the gym teacher also teaches the computer class. Yeah, like my whole research for my PhD was in language theory. So I teach all the programming classes because this is my thing. All right, I'm good at programming. So once you bypass me, then you can teach me stuff. For right now, I got a little bit of a lead. So it's like Usain Bolt versus me in like a race, like a running race. I wonder how much of a head start I actually have to have.
About 10, 30 seconds, maybe.
Possibly, actually. Like, what does he run? He runs like, is it 50 meters or 100 meters? What's the
100 meters probably.
That's 100 meters. That's a sprint.
Yeah.
Yeah.
Okay, so I mean, I feel like I might be able to cover 10 meters in the same time that he can cover 100. But I think I might be able to beat him. If I'm 10 meters from the finish line and he starts 100 meters on the finish line, I feel like I might win that race. I'm not overly confident in that, but I think I might.
We can test this.
It's like, is that a rhetorical question? Would you like to do the math? I'd like to do the math. We actually could figure it out. You have to, because I have pretty good burst speed.
Okay.
I feel like I can go pretty quick from nothing, and I think I can make it 10 meters. I'm going to be too much farther than that. I'm going to not, like, I can run 100 meters probably, but I'm going to need oxygen at the end. Be my feeling. I'm not like in the best running shape. I mean, I'm in a shape, but round is a shape. But it's...
Very true.
All right, so questions about kind of what we did here. Make some reasonable sense?
Can we,
What do you want to do? We want to modify it?
with, we also take in negative numbers?
The short answer is you could. Ours won't work for that because if you're going to store, like, let's say a negative number in binary, you'll learn about this in the computer organization class, but we actually encode it in something called 2's complement.
Okay.
It's a little bit weirder. Yeah, you got to do some interesting stuff here. So this only works for positive numbers.
What if you change the 36 to 1,000?
If you change the 36 to 1,000, you're going to run into. Actually, I think it will probably work in this one because we're not going to actually need something greater than a z.
Yeah.
But you're playing with fire here for. Oh no, we did. So yeah, we were out of range. To have it 1,000, we would need 999. Well, we would need 1,000 unique things. So after 10, we'd need A through Z. Then we need to switch to some other.
Klingon.
Yeah, we need to throw Klingon on there. Whatever. We got to just have more symbols.
So then how do you do like double A in that string up there? In another hex method?
You wouldn't be able to.
Okay.
You would have to use a different solution. Then you'd have to go back to like that dictionary solution.
Okay.
Where the or a list solution. So the string solution only works if you're going to have single character representations, which typically is how it would work.
Mm-hmm.
Yeah, so you'd have to flip over to other languages and stuff. All right, so I'll give you this as a solution to this homework, but now our homework for Friday. Oh, it's going to be so easy.
What is it?
Is going to be base to decimal. And this guy will take in our value and what base it's currently in. And this guy should return the decimal version of value given that value is currently in base. So if that was a 13, that means it's currently in base 13. Make sense? That is to say that base to decimal, this is an example, not the only one it should work for. Base to decimal of BAD 16 should return 2989. the decimal version of the base 16 value BAD. Now we've learned that pattern in class, right?
Yeah.
That's the one where we start at the end and we know how to go through a string in reverse. Place starts at the ones place, times the base, times the base, times the base, times the base, and then just multiply it to the guy on the top. This shouldn't take you any more than 15 hours.
Oh man, I got some time. That's reassuring. Just to burn
Hey, if you didn't start yesterday, you're already behind. Now, when we come to class on Friday, just to give you the heads up, this will probably take us about 3 minutes to solve.
That's what I like to hear.
So just keep that in mind as you're rounding hour 8. All right, I will see everybody on Friday. I'll put this code up on Slack so you have a starting point.
My goodness, that string might look so much nicer.